I've made a couple of videos talking about AM radio and its resilience in the event of a large-scale emergency. I spoke about how in the recent power outages in Spain and Portugal, the news reported that people were buying up all the AM and FM radios to stay connected to the latest news. A few weeks ago I was in Portugal and I visited a few of my favourite shops to see what radios they had, and lots of them had completely sold out. You can always rely on the news to exaggerate things, but in half a dozen stores I visited, the shelves I usually make a beeline for when I'm looking for radios were all empty. I did manage to pick up a radio and do a bit of listening, and there was plenty of AM still on the air across Portugal. In the event of a large-scale emergency here, BBC Radio 4 on AM covers the entire UK on 198 kHz with just 3 transmitters, Droitwich, Berghead and Westerglen. If they lose power, they have huge diesel backups to keep them on the air. As has been widely reported, the BBC wants to cease transmissions on longwave, meaning no UK-wide coverage on Radio 4 on AM. They've said they want to stop broadcasting in the next 12 months. There are calls to delay this, and I think the only reason places like Droitwich are still on the air is due to the fact that the embedded radio Teleswitch signal within Radio 4 is still controlling millions of electricity meters. I'll link a video I made on this below. In the comments on my previous videos in relation to this topic, many of you said, well, if you can back up Radio 4 on medium wave, in an emergency, you can easily back up the UK's FM transmitters instead. My response to this was that it's not that easy. In simple terms, the FM infrastructure in the UK consists of numerous different components. There's BBC National 1, 2, 3 and 4. There's regional and local commercial and community radio, which encompasses hundreds of operators. There's BBC Local Radio, and the BBC services that cover Scotland, Ireland and Wales, as well as Classic FM. Where BBC Radio 4 on longwave uses 3 transmitters, the Radio 4 FM network across the UK needs 215 to achieve the same level of coverage. The UK's complete FM radio infrastructure consists of over 2,100 transmitters. This includes every company and station. Keeping it all on the air in the event of an emergency is impossible, but BBC Radio, and especially BBC Radio 4, has to stay on the air, and in this video I'm going to explain how and why. Now, I can only share publicly available information and my own knowledge here, which is why it's important to distinguish between what happens in a large-scale power cut or a conventional bombing during a war versus a nuclear attack. What happens in a nuclear attack is anyone's guess. It would wipe out the masts at a transmitting station completely. The UK government will of course have plans, so as viewers of a certain age may recall from the Protect and Survive advice, keep your radio in a biscuit tin just in case. It'll shield it from an EMP resulting from a nuclear attack. What happens in a large-scale power cut or localised conventional bombing is much easier to piece together using common sense, publicly available sources, and a bit of top-line knowledge on the UK's FM broadcast infrastructure. Here we have what is known as the Wartime Broadcasting Service. This is an arm of the BBC that's intended to broadcast in the UK either after a nuclear attack or if a bombing destroyed regular BBC facilities in a conventional war. Now, let's be clear here, if there's a nuclear attack on London, major transmitting stations like Crystal Palace or Wartime would be likely destroyed and off the air for the foreseeable future. Even the country's concrete reinforced towers would be either destroyed or damaged beyond use. What the Wartime Broadcasting Service would use in terms of antenna infrastructure in the event of a nuclear attack isn't clear. What I will say, however, is that it's no coincidence that the walls of many large transmitting stations are many feet thick. We can assume that the buildings themselves are designed to withstand a nuclear attack. It's unclear if the Wartime Broadcasting Service is still operational, as plans are kept mainly secret with the BBC and government officials, but it's likely that there's something in place, and it includes some details that would still be relevant today, which I'll include as we go. These include running at reduced power, hardening of transmitter site infrastructure, installing backup generators, and consolidating programming. Let's say the UK has a complete blackout like Spain and Portugal did recently. There's no power whatsoever. This would be classed as a large-scale national emergency. The whole scenario around keeping BBC National Radio on the air is a complex one because there's not just redundancy procedures needed to keep the transmitters themselves on the air, but you also have to be able to feed them. Let's start with power. It's no secret that Crystal Palace transmitter, for example, which radiates an awful lot of digital television, digital radio, local radio, and of course national radio, is fed by two 11 kV cables that feed two high voltage PSUs. This is publicly available information. We can perhaps surmise from this that other larger core sites across the UK, such as Wartime, the first step in the BBC chain, which I'll come to soon, and sites like my local here at home Moss, are similarly fed. The national grid feeds the cables, of course, and the use of two separate cables provides redundancy. They enable a seamless switchover should one fail in order to maintain service. Most transmitter sites have huge diesel backup generators. Again, Wartime, Crystal Palace, Rowridge, Manningtree, Home Moss, Bilsdale, Pontop Pike, basically all of these major players. They can stay on the air for days or even weeks under their own power. Would it be possible to keep both Radio 1, 2, 3 and 4 on the air at the same time? Would it be sensible to? Would it be necessary to? Well, no. Most modern FM radios have sensitive receivers. In the old days they were quite deaf, so in the footprint of most large-scale transmitters, the power levels they use isn't always required. When transmitters were turned down to reduced power for works to take place in the early days, local residents would complain, but today nobody really notices. We can surmise that large-scale transmitters on backup generator power would have their power turned down. Radios 1, 2 and 3 would also be switched off in line with the Wartime Broadcasting Services plan, so that one single national programme could broadcast on BBC Radio 4. This is the most efficient way to ensure the backup generators stay online for as long as possible. It's clear that there's already been some work done behind the scenes to ensure Radio 4 comes out on top. For example, take a look at the BBC National Transmitter map. Now take a look at Classic FM's transmitter map. Classic is the only independent national radio station to broadcast on FM alongside BBC Radios 1, 2, 3 and 4. There's a reason the BBC national stations have more coverage and more reach, contingency planning, as well as their public service obligations. The bigger the site, the more redundancy is built into them. Smaller relays also have diesel generators and can stay on the air for longer periods of time. Like the main sites, these are automatically switched in if a power cut takes place. Some really small relays don't have automatic backup generators, and so an engineer would have to travel to the site in an emergency and take a generator with him. Depending on the severity of the situation, Arqiva may decide to keep the major transmitters on and some of the larger filler sites, but leave out the small, often hard to reach, low population serving relays offline. So what about a UPS? Well, a UPS as a transmitter site isn't there for backup power. While they do play their part in keeping the transmitter on the air, they don't function as a power backup. UPSs in broadcast transmitters merely serve to keep alive what is called either the TIE, transmission insertion equipment, or PI, program insertion equipment alive. That's the equipment that takes the feed and supplies it to the actual high power equipment. It also contains the telemetry to indicate to the control centre what's going on. Let's say the BBC's transmitters are all online in a large-scale power outage. They still need programming in order to radiate. The next challenge is keeping them fed. The few main transmitters serving large populations are fed by fibre nowadays. Some are fed by satellite links, some still have ADSL backups. Most transmitters are relays serving small populations, taking their feed from the main stations. The companies that provide these feeds have their own redundancies in place for keeping them going in an emergency. Fibre networks, of course, rely on electrical power at various points, such as street cabinets and exchanges, to function. During power cuts, these locations can be backed up by battery systems, with larger exchanges also having generators for extended outages. There are systems in place to keep the national network fed without fibre line too. Wartime transmitter is the first step in the BBC transmitter chain. BBC output is sent there first over a fibre line. Using publicly available information, I've located an Arqiva microwave link that runs from Broadcasting House in London to Routum transmitter. We can surmise that this would be used as a feed point in the event of the fibre link failing. One also runs to Crystal Palace 2. Again, we can surmise that this is a backup feed into the transmitter network. In the event of a feed failure, the BBC runs what is known as the rebroadcast standby system on their FM radio network. Periodically, usually late at night, the fibre feeds to all FM transmitters across the UK are cut except Routum. Then, tones and test signals are played from Routum transmitter and they're received by neighbouring transmitters which rebroadcast them. These tones are sort of an audio test card. The tones are relayed from transmitter to transmitter across the country in an outward pattern, with each main transmitter picking up a signal from its neighbour and rebroadcasting it outward for other main transmitters. By the time the tones reach the most distant sites, the signal quality is reduced somewhat, but it ensures that Routum is able to feed every BBC national radio transmitter, ensuring full UK coverage. These tones are assessed to ensure the audio quality is still acceptable. Again, we can surmise that systems like this enable as much of the population as possible can receive a BBC radio signal in a time of emergency. It's not just to keep everyone flush with the latest hits or their 70s favourites, drama plays or sports results. So what about keeping commercial stations on the air? Commercial stations are just that. Their priority and whole MO during a large-scale emergency is different. They're there to make money. They do have some level of backup and redundancy, but there's many different companies and organisations that operate a whole array of different stations. Where Arqiva and the BBC have a set of specific backups in place, the commercial stations in most instances have to fend for themselves. Where the BBC, and specifically Radio 4, has to stay on the air, commercial stations don't have the same obligation. At some transmitter sites, the generator backups for BBC services don't support commercial station infrastructure. In most transmitting stations, BBC transmitters and their supporting equipment are kept separate to commercial station infrastructure. So that's everything I have on how the BBC would keep its national FM network on the air in the event of a large-scale emergency such as a power outage. In the event of a prolonged outage, we can assume that as long as the diesel generators continue to be fed by Arqiva and programming can be sent from Broadcasting House, they'd stay on the air indefinitely. Beyond that is anyone's guess, and let's hope we never have to understand the processes and procedures of keeping them on the air in the event of a nuclear attack.